All right, let's take a mental journey out to the edge of our solar system, to a world that's, well, it's pretty strange.
I'm always up for strange. What are we talking about here?
Well, picture a giant, pale blue planet, but instead of spinning like a top, the way you'd expect, it actually rolls through space on its side. We're going to talk about Uranus.
Wait, hang on. A planet that rolls? That's the question right here. And I have to admit, I've never even considered that possibility. What would that even do to a planet?
Exactly. It changes absolutely everything, from its seasons to its entire history. And that's what makes Uranus one of the most fascinating places we know of.
So to really get Uranus, we've got to go back to its discovery. It all started back in 1781 with an astronomer named William Herschel.
So he was the first person to ever lay eyes on it?
He was. He was sweeping the sky with a powerful new telescope, and he spotted this little, faint object. But he had no idea it was a planet. He actually thought it was a comet.
Okay, so if he thought it was a comet, how did scientists figure out it was actually a planet? I mean, from this far away, I'm guessing it was just a tiny dot of light.
That's a great question. And the answer was all in how it moved. Comets have these really long, stretched-out orbits. But when astronomers tracked this new object, they saw it had a nearly circular orbit around the sun, just like all the other known planets. That was the dead giveaway.
So finding out it was a planet must have opened up a whole new world of questions. Like, what is this new world actually made of?
Right. And that's where we get into what makes Uranus, Uranus. Let's take a look at the anatomy of this so-called ice giant.
So scientists classify Uranus as an ice giant.
Ice giant? That sounds incredibly cold. Does that just mean it's a giant ball of frozen water?
Not exactly. In astronomy, the word ices means things like water, yeah, but also ammonia and methane, stuff that's solid at extremely low temperatures. So Uranus has this small rocky core, and then it's wrapped in this huge, hot, dense ocean of those ices.
And that has something to do with its amazing blue-green color?
It has everything to do with it. The atmosphere has methane gas in it, and that gas absorbs the red light from the sun. So the light that reflects back to us is mostly blue and green.
Okay, so I'm starting to get a picture of it. But how big is an ice giant, really? How does it stack up against Earth?
It's just immense. You could line up 4 Earths side by side just to get across its middle. That massive size gives it enough gravity to hold on to a really, really thick atmosphere.
So we've got a blue-green ice giant, 4 times wider than Earth. That's already a lot to wrap your head around. But you said at the start that it rolls. That has to be the strangest thing about it, right? It absolutely is. And it all comes down to this one incredible number, 98 degrees.
98 degrees? What is that a measure of?
That's its axial tilt. It's the angle that it spins on. To put that into perspective, Earth is tilted about 23 degrees. That tilt is what gives us our seasons. Uranus is tilted over 98 degrees. It's basically lying flat on its side as it orbits the sun.
Wow, so what on earth does that do to its seasons?
It makes them incredibly extreme. A single season on Uranus lasts for over 20 Earth years. For 20 years straight, one pole is in constant sunlight, and then for the next 20 years, it's in total darkness.
And the strangeness doesn't stop with just the planet. The whole system around Uranus, we're talking its rings and its moons, is just as full of surprises.
It has rings? You know, I always think of Saturn when someone mentions rings. Are they big and bright like Saturn's? Not at all. They're pretty much the opposite. They're very thin, very faint, and very dark. They were so hard to see that they were only discovered by accident in 1977 during something called an occultation.
An occultation? What's that?
It's just when one thing in space passes in front of another from our point of view. Scientists were watching Uranus pass in front of a distant star, and they saw the starlight just blink a few times before and after the planet passed by. Those blinks were the rings, blocking the light for just a second.
And what about moons? I see a list of them here on the slide.
Yeah, it has 27 moons that we know of, but these are the 5 biggest. And one of them, Miranda, is one of the weirdest looking objects in the entire solar system. Its surface is just a chaotic jumble of cliffs and canyons.
It honestly looks like it was broken into pieces and then put back together all wrong.
That is the leading theory, that it was shattered by a massive impact and then gravity just sort of pulled it back together. And we only know this because we got one and only one close-up look at the whole system.
For almost 200 years after we discovered it, Uranus was just a tiny, blurry dot in even our best telescopes. But that all changed with one specific mission. Everything changed in 1986, when the Voyager 2 spacecraft flew by. It was humanity's first and, to this day, our only close-up visit to Uranus.
That's just incredible to think about. So what did we learn from that one quick flyby? What did Voyager 2 actually find?
Oh, it was a game changer. It confirmed that the rings were real, it took the first detailed photos of the moons, including Miranda, and it discovered that the magnetic field is also totally bizarre. It's tilted and way off-center from the planet itself.
So it sounds like it answered a few questions, but it might have raised even more.
That's a perfect way to put it. Even after that visit, Uranus is still packed with major mysteries.
Okay, this has to be the biggest one. We know it's tilted completely on its side, but why? What could possibly knock an entire planet over like that?
The leading theory is basically a cosmic catastrophe. The idea is that billions of years ago, when the solar system was young and chaotic, a huge object, maybe the size of Earth, just slammed into Uranus and knocked it over. So a giant cosmic collision. That's our best guess, but it's really important to say that it's still just a theory. Scientists are actively trying to solve this exact puzzle right now.
And the tilt isn't the only big puzzle, right? There's something else that's strange about its temperature, isn't there? Why is it so cold?
That's right. Other giant planets, like Jupiter and Saturn, have hot cores. They actually give off more heat than they get from the sun. But Uranus is different. It's strangely cold inside and radiates almost no heat of its own.
And could that also be related to that giant impact theory?
That's one of the main ideas, that whatever collision knocked it over also allowed most of its internal heat to escape out into space. But just like the tilt, we just don't know for sure yet.
So with all these huge unanswered questions, why is it so important to study this one weird, distant planet?
Because Uranus is our best local example of a really common type of planet that we're now finding all over the galaxy. These ice giants orbiting other stars. By understanding the violent history and strange physics of Uranus, we can better understand how countless other worlds out there might have formed. It's really a bridge to other solar systems.
And that's really the story of Uranus for now. It's a planet that challenges all our ideas of what's normal and reminds us that there are still profound mysteries right here in our own cosmic backyard. It really feels like a perfect example of how the more we learn, the more we realize we don't know. The universe still has many pages left to turn.